Good morning and thank you for the invitation to the final of the Emerging Technologies competition of the Royal Society of Chemistry. My name is Juan Bermudez. I am a postdoctoral fellow at the University of A Coruna in Spain, and today I'm glad to introduce you our emerging technology of low pressure and zero emissions hybrid refrigerants for cooling applications. Nowadays, refrigeration technologies have a critical impact in the global warming. First, because they waste up to 40% of the energy that they use, and second, because they need refrigerant gases, mainly greenhouse gases, that can easily escape to the atmosphere. So how do we cool the world of the future? Our mission in the University of A Coruna is to provide new solid-state refrigerants as an efficient, safe, and eco-friendly alternative to the refrigeration sector that already accounts for around 20% of the global energy consumption, with a total market size of over $250 billion, and that is responsible for the 7% of the carbon emissions in the world. And due to this environmental impact, the international regulations are reducing the use of the most common refrigerants, which are mainly fluorinated gases or F-gases. In that regard, from 2015 to 2030, the use of these gases will be reduced by as much as 80%. Moreover, the new alternatives that do not contribute to the global warming are still toxic or flammable gases such as hydrocarbons, ammonia, or CO2. Therefore, there is no doubt that we need to find new alternatives that are safer not only for the environment, but also for the final user. In our lab, we work to replace these refrigerant gases by solid-state refrigerants, also known as barocaloric materials, that cannot escape to the atmosphere. In a similar way to the refrigerant gases, solid-state barocalorics can generate cooling under the application of pressure. However, while gases can operate under pressures between a few bar and 150 bar, traditional barocalorics require pressures of over 1000 bar. In our lab, for the first time, we have been able to reduce this working pressure down to 70 bar. And how do we do that? We do that by combining flexible organic ligands, inorganic cations, and organic molecules to obtain organic-inorganic hybrid refrigerants that are very sensitive towards pressure. And even more, we can engineer our materials to operate in different seasonal and environment temperatures. In this table, we compare our hybrid barocalorics with other refrigerants in the market, such as solid-state magnetocalorics or thermoelectrics, and some of the principal refrigerant gases. Our materials not only promise to be more efficient, but they are also low cost and they cannot escape to the atmosphere, which eliminates direct carbon emissions and facilitates the recovery in case of any leak. Moreover, they are not flammable or toxic compounds, and even more, our technology is easily scalable and offers plenty of room for innovation. For the successful development of our project, we work in a multidisciplinary team, integrated by a group of experts in chemical design and synthesis, a group of experts in thermal properties, and a group of experts in energy engineering. It is important to highlight that this is a very young project. It started in 2017, when we published our first results in Nature Communications that were recognized with 3 national research awards. Soon after that, between 2018 and 2020, we were able to raise €500,000 in research grants. And now, by the end of this year, we expect the delivery of our first prototype, and we plan to reach TLL6 by the end of 2021. Therefore, our next target will be to raise €1 million to reach TLL8 by the end of 2023. Our solid refrigerants and refrigeration prototypes are protected under trade secrets and patents that have already been granted or that are under examination. In this very early stage of our technology, we plan to target the markets of wine coolers and portable AC units because we can easily adapt our materials to those technologies, and that will facilitate our fast entrance in the market. However, in the near future, we plan to target high-value markets by exploring gas-solid hybrid systems, movement to cooling self-conversion, and thermal energy storage, where we believe that our materials can be a game-changer technology. In that regard, we have already received the interest of some startups and multinational companies with base in Spain and UK. We believe that we can change the way we cool the world and protect our environment. Let me finish by thanking you for your attention And please do not hesitate to contact us if you are interested in discussing partnerships, licensing, or consultancy.